Hey, everybody. So today we're looking at trig identities. We've been looking at identities for a while now. The identities that we're studying today are the product to sum, and then we'll see the sum to product. The product to sum identities are sine alpha sine beta equals 1/2 times the quantity cosine alpha plus minus beta minus cosine alpha plus beta. Cosine alpha plus cosine alpha times beta equals 1/2 cosine alpha minus beta plus cosine alpha plus beta. Sine alpha cosine beta equals 1/2. I lift off all of these parentheses. They'll be fixed on your notes. Sine alpha cosine beta equals 1/2 sine alpha plus beta plus sine alpha minus beta. And finally, cosine alpha sine beta equals 1/2 sine alpha plus beta minus sine alpha minus beta. The goal of this entire section, the product to sum and sum to product, is that you are familiar with these identities and that you can use them. You do not have to memorize these. In fact, I would encourage you not to memorize these. Well, let's use the old-fashioned sign of the sum minus and sign of the difference identities and see what we get. So I know that sine of alpha plus beta is the sine of alpha cosine beta plus sine of beta cosine of alpha. And the sine of alpha minus beta is exactly the same except with a minus sign. So we have sine alpha cosine beta minus sine beta cosine alpha, and we're going to subtract them. So on the left-hand side, we have sine alpha plus beta minus sine alpha minus beta equals, and on the right-hand side, I have a sine alpha cosine beta minus sine alpha cosine beta. So those terms go away. I still have a sine beta cosine alpha, sine beta cosine alpha, and then minus a negative. So plus another sine beta cosine alpha. So we get 2 times sine beta cosine alpha equals the difference of the sum of the sines and the difference of the sines. And do you see, if I solve both sides of this equation for sine beta cosine alpha, or sine alpha cosine, let's see, where is it? Sine alpha cosine beta, it doesn't really matter, that I would get 1/2 times the quantity sine alpha plus beta minus sine alpha minus beta. So I just wanted you to see how these identities come to be. Again, I want you to have access to these identities. I want you to have them easily at hand, but please do not try to memorize them. If you want to memorize any of the identities, memorize the sum of the sines, the difference of the sines, the sum of the cosines, and the difference of the cosines. Okay, let's use these identities. We use them to simplify sine 8x times the cosine of 5x. Okay, I've got sine A cosine B. So I'm going to write, or sine alpha cosine beta. So let's see. I want, this is sine sine, or this is cosine cosine, sine cosine. Here we go. Sine cosine. So we've got 1/2. There we go. The sine of alpha plus beta plus the sine of alpha minus beta. Where here, alpha is 8x and beta is 5x. So I get 1/2 times the sine. Well, what is alpha plus beta? What is 8x plus 5x? Excellent. The sine of 13x plus the sine and alpha minus beta. 8 minus 5 is 3. So we get 3x. And there we go. That's as simplified as we can get it. The key thing is we had a sine and a cosine before, and now we just have sines. Well, let's simplify the sine of 13 pi over 6 times the sine of 7 pi over 6 using the same thing. So let's see. We've got sine, sine. So I'm going to use this first identity. I'm going to let alpha be 13 pi over 6 and beta be 7 pi over 6, where the sine of alpha times the sine of beta is 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. Alpha minus beta, 13 minus 7 is 6. So let's see, 13 pi over 6 minus 7 pi over 6 is 6 pi over 6, but that's pi. So we've got cosine of pi minus cosine of, and now we're going to add alpha and beta, 13 pi over 6 plus 7 pi over 6. 13 and 7 are 20. So we have 20 pi over 6. We can reduce by 2. That gives us 10 pi over 3. 10 pi over 3 is larger than 2 pi. Let's see. So we've got 10 pi over 3. 2 pi, if I want to have a common denominator, I would multiply by 3 over 3. That gives me 10 pi over 3 minus 6 pi over 3. 10 minus 6 is 4. So the sum, let's see, are we looking at the sum? Yes. The sum, this is not the same angle, but this is a coterminal angle. It will have the same sine and cosine. So our coterminal angle for 10 pi over 3 will be 4 pi over 3. So I'm going to put 4 pi over 3 here. What is the cosine of pi? Look on your unit circle. Did you find it? Okay, yes, -1. And we're subtracting. What is the cosine of 4 pi over 3? First, which quadrant is 4 pi over 3 in? Yes, third quadrant. It's going to have the same cosine as pi over 3. Let's look. Here's pi over 3. Remember the x coordinate is cosine, and I can see here the y coordinate is larger, so the y coordinate must be square root of 3 over 2. The x coordinate is much shorter, so it must be 1/2. But we're in the third quadrant, so I'm going to have -1/2 for the cosine of 4 pi over 3. So -1 minus -1/2. Let's see. Minus a negative is positive. -1 plus 1/2. Let's take this by steps. -2 over 2. Do you see I rewrote -1 as -2 over 2. And now I'm adding 1/2. -2 plus 1 is -1. And now I multiply across, and we get -1/4. Just for fun, let's check this using an approximation. So I'm just going to play with the calculator. All right, so we've got 13 times pi divided by 6. And I don't want it in degrees, I want it in radians. Okay, so we've got 13 times pi divided by 6. And we want to find the sine of that, which is 0.5, cool. And we want to find the sine of 7 pi over 6. 7 times pi divided by 6 equals sine. We get also 1/2, but that should give us positive 1/4. So let's check the work. Cosine of pi is -1. Cosine of 4 pi over 3 is -1/2. That's positive. Our work looks good, so I'm going to pause it and check this out. Hey, I'm back. I don't know what was up with the calculator, but this answer is correct. The sine of 13 pi over 6, well, 13 pi over 6 is greater than 2 pi, because we've got 13 pi over 6 minus, let's see, 2 pi over 1. If we want to get a common denominator, we would multiply by 6 over 6. That gives us 13 pi over 6 minus 12 pi over 6, which is just pi over 6. The sine of pi over 6 is 1/2. 7 pi over 6 is in quadrant 3. So its sine is -1/2. And if you multiply them, you see that you do get -1/4. All right, let's simplify cosine sine. Let's find, here we go. Cosine sine, if we let alpha be 25 pi over 24 and beta be 19 pi over 24, then we get the cosine of alpha times the sine of beta is 1/2 times the sine of the sum minus the sine of the difference. This time it's nicer because 25 pi over 24 is not a nice value on the unit circle. So we really do need the identity to get to nice values. We need the sum of alpha and beta and the difference of alpha and beta. So let's go ahead and do that. Alpha plus beta, that's 25 pi over 24 plus 19 pi over 24, 25 and 19, let's see. That's almost 25 plus 20, that would be 45, minus 1 is 44. Pi over 24. But we can reduce this. They're both divisible by 4. Oh, cool. You could do it by 2 and then 2 again. 4 goes into 44 11 times. 4 goes into 24 6 times. And now I've got 11 pi over 6 for the sum. So this is equal to 1/2 the sine of 11 pi over 6 minus the sine, and let's find the difference. Alpha minus beta, 25 pi over 24 minus 19 pi over 24. And that leaves 6, is that right? Yes, 6 pi over 24. We can divide numerator and denominator by 6, and we're left with pi over 4. The sine of 11 pi over 6, that'll be the same as pi over 6, the sine of pi over 6, which is 1/2. But in the fourth quadrant, sine is negative. So this will be negative 1/2. The sine of pi over 4 is square root of 2 over 2. So now we can simplify. We get 1/2 times negative 1/2 minus square root of 2 over 2. We can multiply through by the 2, and we get negative 1/4 minus square root of 2 over 4, or we could write it as one fraction. Negative 4. I'm going to put this negative out front, and then I'll have 1 plus square root of 2 in the numerator. It really doesn't matter how you write the answer. The key is that you can't combine 1 and square root of 2. You have to write them as separate terms. Awesome. Okay. Let's verify the identity. Sine of x plus y times the sine of x minus y equals sine squared x minus sine squared y. Let's see, how do we want to do that? Let's do it two different ways. In the first way, let's use sine alpha, sine beta. Let's use the fact that sine alpha times sine beta is 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta, where alpha equals x plus y and beta equals x minus y. Okay, so goodness, let's do the same thing that we did last time. Let's find alpha plus beta and alpha minus beta. X plus y plus x minus y. Well, we're going to get 2 x's and the y's add away. So we get 2x. Alpha minus beta is x plus y minus x minus y. This time the x's add away and we get y minus negative y. That's 1 plus y is 2y. So we get 1/2 cosine alpha minus beta was 2y minus alpha plus beta was 2x. And now, because we want to get to not 2y or 2x, but we want to get to x and y. That means we need to use the double angle formula for cosine. And I want to use the form that just has sines. So let's see. Cosine of 2 alpha is 1 minus 2 times the sine squared of alpha. That's the one we're going to use because the goal has only sines. So we have 1/2 times 1 minus 2 sine y squared minus 1 minus 2 sine squared x. Okay, now I see that 1 minus 1, the ones go away. Then I've got -2 sine squared y minus a negative. So plus 2 sine squared x. Hey, if I divide these by 2 or multiply by 1/2, the 2's on both terms go away. Let's do that in 2 steps. I can factor out a 2, and we'll have negative sine squared y plus sine squared x. The 2's divide out, and the goal was to write sine squared first, sine squared x first, and that's good because the sine squared y is negative, and that we've got it. Sine squared x minus sine squared y. Okay, that was the first method. Let's do it another way. Let's use the sum, the sine of the sum of 2 angles and the sine of the difference of 2 angles. Let's see which way was easier. So the sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and the sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. We're going to expand both of these, so we've got a big product. Since I have sine x plus y times sine x minus y, I'm going to have the product of sine x cosine y plus cosine x sine y times sine x cosine y minus cosine x sine y. But let's look at what we've got. The first terms are the same, sine x cosine y. The second terms are the same, cosine x sine y. One has a plus sign, one has a minus sign. This is the pattern a plus b times a minus b. And we remember this is the difference of 2 squares factored. So the product is going to be a squared minus b squared. So we're going to have the first term squared minus the second term squared. So sine squared x cosine squared y minus cosine squared x sine squared y. But this isn't quite the goal we wanted. We wanted only sines in the answer. So I need to replace the cosines with 1 minus sine squared x, because we know that sine squared x plus cosine squared x is 1. If I want to solve for cosine squared x, I have 1 minus sine squared x. And that's exactly what we're going to do for both sine squared, cosine squared y and cosine squared x. So instead of cosine squared y, I'm going to write 1 minus sine squared y. and then minus. Instead of cosine squared x, I'm going to write 1 minus sine squared x. And that's times sine squared y. And now I need to multiply everything out. Sine squared x times 1. Sine squared x times negative sine squared y. So negative sine squared x sine squared y minus 1 times sine squared y. So minus sine squared y, and then negative times a negative is a positive. So plus sine squared x times sine squared y. And check it out. The sine squared x we want, right? It was in our goal. The sine squared y we want, and it's negative. That's good. That was in our goal. But these middle terms were not. But check it out. We've got negative sine squared x times sine squared y and a positive sine squared x sine squared y. So those add away, and we're left with sine squared x minus sine squared y. So you can see both of these methods work. It was a little sweeter using alpha, sine alpha times sine beta, where alpha was x plus y and beta was x minus y, but it really doesn't matter. They both work. Okay, first we're going to see how we can find an identity for sine alpha plus sine beta. So let's look at what we have already. If I want to find sine alpha plus sine beta, sine plus sine, I'm going to use this second one. So I'm going to remember that 1/2 times the sine of alpha plus beta plus the sine of alpha minus beta equals the sine of alpha times the cosine of beta. But here, let's make this x, and let's make this y, so we don't have the same variables. So here, alpha plus beta is x, and alpha minus beta is y. We need to find out what x is. Pardon me, just a moment. Okay, we need to find out in terms of x, what is alpha and what is beta? So if we add these two equations, we're going to get on the left 2 alpha, the betas. Do you see the betas add away? And on the right, x plus y. So in terms of x and y, we get that alpha is equal to x plus y divided by 2. Let's find beta doing the same thing. Let's take the two equations and subtract them. This time we have alpha minus alpha, so the alphas add away, beta minus negative beta. So that's beta plus beta, which is 2 beta. And on the right, x minus y. And again, we're going to divide both sides by 2, and we get beta is equal to x minus y over 2. So now our formula looks like 1/2 times the sine of x plus the sine of y equals sine x plus y over 2 cosine x minus y over 2. But we wanted just sine x plus sine y. We didn't want this 1/2. So I'm going to multiply both sides by 2. And we get that the sine of x plus the sine of y is equal to 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. And those formulas are right here. So we have the sine of alpha plus the sine of beta is 2 times the sine of the sum of the angles divided by 2 times the sine of the difference of the angles divided by 2. The cosine of the sum is 2 times the cosine of the sum divided by 2 times the cosine of the difference divided by 2. The sine of alpha minus beta is 2 times the cosine of the sum divided by 2 times the cosine of the difference divided by 2. And the cosine of the difference is -2 times the sine of the sum divided by 2 times the sine of the difference divided by 2. Right, so let's use those identities. For some reason, our book likes using degrees, and sometimes that's important. So we're going to do a few examples with degrees. I have the cosine of 345 degrees minus the cosine of 75 degrees. And if you look on your unit circle, neither of these values is a nice value. In other words, neither of these values is a point on our unit circle. So I'm going to use the cosine of the difference, cosine of alpha minus cosine of beta equals -2 times the sine of alpha plus beta over 2 times the sine of alpha minus beta over 2, where alpha equals 345 degrees and beta equals 75 degrees. If we add, we get 11, 12, we get 420 degrees. 420 is larger than 360, so I'm going to subtract off 360 to find a coterminal angle between 0 and 360. 12 minus 6 is 6. So we get 60 degrees is our coterminal angle between 0 and 360. Then alpha minus beta, 14 minus 7 is 7. And then we'll get a 2. 270 is between 0 and 360. So this is a good angle. Let's see, what is that angle? 270 just one moment, I've got a kitten. All right, I'm back. So yes, 270 degrees, 270 degrees is 3 pi over 2. So it's equivalent to 3 pi over 2. So we know where it is. So now I want to figure out, I've got the sum and the difference. Oh, I need to divide both of them by 2. So here, alpha plus beta divided by 2, that's 60. Divided by 2 is 30 degrees. Alpha minus beta over 2 is 270 degrees divided by 2 is 135 degrees, and 135. That's like 3 pi over 4. So this is in the second quadrant. Okay, so now we can do this. The sine the sine of 30 times the sine of 135. Okay, the sine of 30 degrees is 1/2. The sine of square root of 3 over, the sine of pi over 4 is square root of 3 over 2. We're in quadrant 2, but sine stays positive in quadrant 2. So we get still square root of 3 over 2. And we're multiplying by -2. So we have 1/2 times square root of 2 over 2. The negative, the one of the 2's divides out, and we still have a negative square root of 3 over 2. Very cool. Just one moment. Liney do. I'm back. Oh, here's another fun one. Let's verify the identity cosine of 7x plus cosine of 5x divided by cosine of 7x minus cosine of 5x equals the cotangent of 6x times the cotangent of x. We're going to use the cosine of the sum and the cosine of the difference formulas. The cosine of the sum is 2 times the cosine of 7x plus 5x divided by 2 times the cosine of 7x minus 5x over 2. The cosine of the difference is 2 times, -2 times, the sine of the sum times the cosine, times the sine of the difference, 7x minus 5x over 2. So now we've got, that's definitely going to be negative. Okay, so now we've got these 2's divide out. We are going to have a negative up front. 7 plus 5 is 12. 12 divided by 2 is 6. So we're going to have cosine of 6x. 7 minus 5 is 2. 2 divided by 2 is 1. So cosine of x, and it will be divided by the sine of 6x times the sine of x. And then we're going to group the first and the second. Cosine of something divided by sine of the same thing is cotangent. So we'll get negative cotangent of 6x, and then cosine x divided by sine x again is cotangent of x, and that was our goal. I'll fix the notes so that when y'all see them, they'll be correct. Oh, okay, and this is the beginning of the next lecture, so I'm going to pause.